Two vertical milling machines stand side by side, both wearing the same coat of oil, dust, and decades of hard use. One carries a name that almost anyone who has ever stepped into a machine shop can recognize: Bridgeport. The other carries a name that many younger machinists have to squint at twice before reading it correctly on the cast iron body: Tree. If you ask the old machinist in that shop, the man who has spent more than 40 years behind a mill, which one he would keep if he had to sell the other, his answer might surprise anyone outside the trade. He would point to the Tree. Bridgeport became one of the rare phenomena in industrial history. Tree did not. But among mold makers and tool room machinists, among people who lived by tenths and thousandths of an inch and by surface finishes clean enough to reflect light, Tree's 2UV and 2UVR mills were once passed from one craftsman to another like a professional secret. This was the upgraded Bridgeport that almost nobody knew about. If engineering quality were truly what decided the winners, why did the machine respected by the most demanding machinists fade into obscurity, while the machine that was merely good enough became the symbol of an entire era? This is the story of Tree Machine Tool and of one of the cruel paradoxes of the American machine tool industry. If you care about the machines and companies that built the industrial world, like this video and subscribe to the channel so you do not miss the next story. In the first half of the 20th century, the industrial belt of southeastern Wisconsin, stretching through Milwaukee, Racine, and Kenosha, was one of the densest concentrations of mechanical skill in North America. This ecosystem produced a remarkable number of names in American tools and machine tools, from Milwaukee Tool in portable power tools to Kearney and Trecker and Giddings and Lewis in heavy-duty machining equipment. American mass production, from Detroit automobiles to farm machinery and later aviation, rested on a paradox. To produce millions of identical parts on specialized machines, manufacturers first needed an army of tool and die makers to build the dies, fixtures, jigs, locating devices, and cutting tools that made those production lines possible. Those workers did not live on the assembly line. They worked in small shops hidden inside larger factories, where every part was a separate problem, every cut demanded flexibility, and the rigid logic of mass production was not enough. Every one of those tool rooms needed a particular kind of machine, a vertical mill accurate enough for delicate work, flexible enough to move between dozens of different operations in a single day, and compact enough to fit inside the tight spaces of a shop floor. Bridgeport arrived and became a runaway success. It was good enough. But for mold makers working at the edge of precision, for people who knew that a small trace of chatter on a mold surface could mean hours of hand polishing, good enough was not enough. They wanted a machine built around the familiar knee mill architecture, but heavier, more rigid, with a more precise head and a smoother spindle under heavier cutting conditions. Most of the market did not need that, and was not willing to pay extra for it. But a significant minority did. That was the opening Tree stepped into, and like many stories from industrial Wisconsin, it did not begin with a grand business plan. It began with a local machine shop trying to solve its own problems. Racine, Wisconsin, in the early 20th century, was a classic Great Lakes industrial city, small enough that shop owners knew one another by name, large enough to have year-round work from automobile, tractor, and agricultural equipment manufacturers spread across the Midwest. In that environment, tree began in a pattern so familiar that it almost became a formula in the American machine tool industry. A local job shop took on contract work, survived on difficult jobs that others turned away, improved the machines on its own floor while trying to solve its own problems, and eventually realized that those improvements might be the real product worth selling. Tree rose from the shop floor culture of Racine according to exactly that logic. Tree's engineers carried the mindset that people in the trade might describe as tool makers thinking like machine operators. Every design decision answered a real problem that they or their customers had actually encountered. Why did the machine body need to be cast thicker? Because they had stood in front of a mill that shuddered when the cutter dug into hard steel, and they had watched the finish on a part get ruined. Why did the head need to be more precise? Because they had lost half a day realigning a loose head in the middle of an urgent job. That philosophy did not create the cheapest machines. It created machines that the most demanding buyers were willing to pay more for, because in every design detail they could recognize an answer to their own daily frustrations. But a local shop with a good product remains a local shop until history intervenes. For Tree, as for almost the entire American machine tool industry, that intervention came in the form of the Second World War. When the United States shifted into a wartime economy, demand for machine tools exploded so sharply that the federal government effectively absorbed the full productive capacity of the industry. Every aircraft plant, every shipyard, every tank production line needed tool rooms, and every tool room needed accurate milling machines. Major manufacturers such as Bridgeport ran at full capacity and still could not meet demand. Orders spilled over to smaller producers, and companies with genuinely good products suddenly had a chance to prove themselves before a national customer base they never could have reached in peacetime. For Tree, the war years did what no sales campaign could have done. They put its machines into the hands of thousands of tool and die makers across the United States, under the harshest working conditions imaginable, 3 shifts a day, 7 days a week, in places where every weakness in a machine would reveal itself within months. Tree's machines passed that test. When the war ended, the company emerged with an asset more valuable than any contract, a reputation among professionals. Machinists who had run tree mills in defense shops carried their impressions of the machine's rigidity and stability back into civilian tool rooms, mold shops, and factories, shifting back into peacetime production. From a local shop in Racine, Tree had become a name known and respected by tool rooms across the country. At the same time, in Connecticut, Bridgeport also emerged from the war not only with a reputation, but with tens of thousands of machines in the field, an R8 collet system on its way to becoming an industry standard, and a position inside vocational schools that no rival could easily dislodge. The two companies entered the golden age of the American knee mill with very different weapons, and as the next part of the story shows, that difference, not the quality of the cast iron, would decide who became a generic name and who became a footnote in the memory of the trade. To understand why Tree's 2UV and 2UVR mills earned such respect among mold makers, it helps to understand the structure of a knee mill. Its architecture revolves around 4 main elements. The knee is the large casting that rides on the column and moves vertically by a screw, carrying the full weight of the table and the workpiece. The saddle sits on the knee and travels forward and backward. The table sits on the saddle and travels left and right, holding the work firmly in place. At the top of the column is the head, the assembly that contains the spindle, where all the energy of the machine is concentrated into the cutting tool. These four elements form a chain of force, and that chain is only as strong as its weakest link. From this structure comes the physical law that governs the entire craft of milling. Rigidity decides everything. When a cutter bites into steel, the cutting force does not disappear. It travels back through the spindle, through the head, down the column, through the knee and the table. If any point in that chain has too much flex, the structure vibrates, and that vibration appears directly on the surface of the part as tiny waves known in the trade as chatter. For ordinary work, a little chatter may be tolerable. For moldmakers, machining cavities where every surface defect can be reproduced in hundreds of thousands of molded parts, chatter is an enemy that must be eliminated at the source, in the iron of the machine itself. This is where tree made its wager. Compared with a Bridgeport in the same general class, tree machines were cast with heavier, thicker bodies, with reinforcing ribs designed to absorb and distribute cutting forces rather than send them back into the tool. That mass was not the clumsiness of an outdated design. It was a deliberate choice, because in the world of machine tools, cast iron is one of the finest natural vibration dampers ever used by human beings. Tree's variable speed head was regarded by users as smooth in operation, allowing machinists to adjust spindle speed continuously and find the sweet spot for a given material and cutter without stopping the machine to change belts. And the spindle, the heart of the entire system, was said by professionals to hold tolerance better under heavy cuts, precisely where lighter machines began to show their limits. It should be said clearly that much of this comparison comes from the accumulated experience of machinists over many decades, repeated consistently in trade conversations and professional forums, rather than from independent controlled testing. But in machining, the collective experience of thousands of people whose livelihoods depend on thousandths of an inch is a form of evidence that cannot be dismissed lightly. When the most demanding people in the trade tell the same story about two machines, that story usually points to a real technical difference. More important is how that technical difference became an economic difference. For a mold shop, a better surface finish straight off the mill meant fewer hours of hand polishing, and polishing mold cavities by hand is one of the most time-consuming and skill-dependent steps in the entire process. Less vibration meant longer tool life, fewer scrapped parts, and the confidence to take deeper cuts, reducing total machining time. Added together, a tree might cost more than a Bridgeport on the day it was purchased, but on difficult parts, it could cost less per finished job. That was the kind of calculation only buyers spending their own money and living by the quality of their work had the patience to make. It was also the kind of calculation that never became a mass market sales argument. From this emerged an informal hierarchy in the trade, summed up in a line old machinists still pass on to younger ones. Bridgeport was for everyone. Tree was for the picky ones. That statement was one of the highest compliments a machine could receive. It also contained the seed of the problem, because the market for everyone is always many times larger than the market for the picky ones. A technical reputation becomes a business only when it finds a path to the buyer, and in the middle decades of the 20th century, Tree's path ran through industrial dealers, the machine tool distributors who served factories and production shops directly. Tree's customer base reflected the nature of the product, tool rooms inside large manufacturing companies, where the most difficult parts in the plant were handled, independent mold shops that lived by precision, defense facilities that already knew tree machines from the war years, and some vocational schools that wanted students to train on equipment above the ordinary standard. It was a high-quality customer base, loyal and willing to pay, but it also had a ceiling. Quality always has a price, and that price is not found only on the invoice. A thicker casting meant more iron, more machining time, and more scraping and fitting on every machine that left the factory. A spindle that held tighter tolerances meant more demanding assembly and inspection procedures, and a production line that was harder to accelerate. The result was higher cost per machine, a higher selling price, and production volumes far below Bridgeport's. In years when the market was broad and growing, that structure worked. Tree sold fewer machines, but each machine carried a justified margin, and professional buyers did not bargain against quality. But beneath that golden age, a seed had already been planted. A high-quality, low-volume company is like an organism optimized for a particular ecosystem. It thrives when the ecosystem is stable. It is among the first to suffer when the climate changes. Meanwhile, on the other side of the market, Bridgeport was playing an entirely different game. To understand Tree's fate, that game has to be understood. Bridgeport did not win by building a better machine. It won through volume and ecosystem. More than 370,000 machines in the field created a critical mass no competitor could match. Parts were everywhere. Repairmen knew the machines by heart, and third-party tooling and accessories were designed by default around Bridgeport dimensions. The R8 collet system developed by Bridgeport became an open standard across the industry, which meant that every shop's investment in tool holding automatically pulled it further into Bridgeport's orbit. Most important of all, Bridgeport captured vocational schools. Every year, thousands of young machinists entered the trade with their hands already trained on the feel of a Bridgeport. Every hand wheel, every lever, every motion. When those machinists went into the workforce, opened shops, or recommended equipment purchases, they chose what they knew. A generation trained on Bridgeport bought Bridgeport. The loop fed itself, year after year. Tree never built a loop like that, and to be fair, its business model made that almost impossible. To enter vocational schools at scale, a company had to sell machines cheaply and in high volume, which meant abandoning the very cost structure that made Tree's quality possible. To create an industry standard, a company needed overwhelming installed volume to pull the accessory market along with it. Tree chose depth over breadth, and within that choice it did almost everything right. The problem was that depth creates respect, while breadth creates a moat, a defensive barrier that quality alone cannot cross. As long as the contest was about cast iron and spindles, Tree remained safe inside its fortress of quality. But the contest was about to stop being about cast iron. The 1970s and 1980s brought a fundamental shift to the American machine tool industry, deeper than any disruption before it, because it did not merely change who made the better machine. It changed the definition of what a good machine was. Numerical control, first NC and then CNC, placed the computer between the machinist and the cutting tool. Tool paths were now programmed rather than hand-cranked, and that overturned the value system of the entire trade. Competitive advantage moved from cast iron to electronics and software, from the smoothness of sliding ways to the reliability of control boards, from the scraping skill of the machine builder to the ability to write and maintain code. And a new variable became decisive: delivery time. In the world of manual machines, Customers waited for a good mill. In the world of CNC, customers needed the machine on the floor quickly so it could start making parts. A manufacturer that delivered late watched the order go to someone else. Tree did not stand still in the face of this wave, and that deserves to be recognized, because history is often unfair to serious transitions that do not fully succeed. The company developed the Tree Journeyman line, with the Journeyman 325 as a notable example, a CNC bed mill aimed at job shops, small and medium-sized machining businesses that took on varied work and needed a numerically controlled machine that was rigid, flexible, and reasonably priced. The choice of a bed mill architecture rather than a knee mill showed that Tree's engineers understood what they were doing. For CNC machining, a fixed table on an integrated cast base offered a rigidity better suited to servo-controlled motion. The Tree Journeyman was a serious attempt by a traditional American machine tool builder to enter the digital age, carrying with it decades of accumulated knowledge about iron, vibration, and thermal stability. And within its segment, the product found buyers. Shops that purchased journeyman machines were generally satisfied with what they received, a CNC machine that inherited Tree's philosophy of rigidity and did the work it was designed to do. If the story were only about product quality, this would be a successful chapter. But Tree's problem in the CNC era was never simply product quality. The problem was that the playing field had changed, and the new rules were written by competitors with entirely different structures. From Japan and Taiwan came CNC machines built around standardized Fanuc controls, entering the American market with a formidable formula, controls that operators could learn once and use everywhere, consistent quality from high-volume production, competitive pricing, and delivery times measured in weeks rather than months. When a job shop compared a journeyman with a Fanuc-based machine, it was not merely comparing two machines, it was comparing two ecosystems. The Fanuc ecosystem came with tens of thousands of trained operators, a global parts supply, and service technicians spread across the world. Then from California, a domestic competitor appeared with an even more direct formula. Haas sold CNC machines with public list prices, breaking the opaque quoting traditions of the industry, and used vertical integration to control costs from castings to controls. Before Haas, machine buyers negotiated in the dark. After Haas, they could open a catalog and compare numbers. For companies like Tree, whose value rested on harder-to-quantify virtues such as rigidity and long-term durability, a market that reduced everything to printed numbers stripped away one of their strongest weapons. That was the bitter paradox of this period. Tree had done the hard thing. It had built a credible CNC machine that carried forward its technical heritage. But the real difficulty of the new era was no longer only building a machine. It was running a business machine capable of producing quickly, delivering quickly, supporting customers globally, and competing on every dollar in the quoted price. In that arena, a century of cast iron know-how was no longer a moat. It began to look like a cost burden. And when three pressures converged in the 1980s, good enough imports, the cyclical downturn of the industry, and the cost structure of a high-quality, low-volume manufacturer, Tree's time began to run out. What happens when a company does everything right under the old rules, only to discover that the rules no longer exist? That is the next part of the story. The journey from Racine to ZPS Tree, where the name on the casting survived longer than the company that put it there. The 1980s struck the American machine tool industry not with one blow, but with three at once. To understand why tree could not survive, those blows have to be seen as converging forces rather than separate events. The first pressure came from outside, the wave of imported machines from Japan and Taiwan, built around standardized Fanuc controls with increasingly stable quality and prices that traditional American cost structures could not match. Those machines did not need to be better than American machines. They only needed to be good enough for the majority of work, cheaper, and available faster. For most buyers, those three factors ended the argument. The second pressure came from the industry cycle itself. The recession of the early 1980s shrank capital investment across the economy, and as in every downturn before it, machine tools were among the first things cut from factory budgets. The situation grew severe enough that the federal government intervened with voluntary restraint agreements with Japan and Taiwan beginning in 1987, an implicit admission that the industry was standing near the edge of extinction. But import quotas did not save anyone. They merely prolonged the dying process. Within a decade, names that had once been pillars of the industry collapsed or were absorbed. Cincinnati Millicron withdrew from the machine tool business. Kearney and Trecker, Tree's Wisconsin neighbor, was folded into Giddings and Lewis, and Bridgeport itself, the symbol of the knee mill category, began its own long slide through corporate owners before going bankrupt early in the next century. The third pressure, and for Tree the cruelest one, came from within, the cost structure of a high-quality, low-volume manufacturer. This was the seed planted during the Golden Age, as earlier parts of the story have shown. Heavier castings, tighter spindles, more careful assembly. All the qualities that had built Tree's reputation also meant higher fixed cost per machine. In a growing market, that model worked because the premium segment could support the margins. But when the market contracted and import competition pulled prices downward, a low-volume producer had no room to retreat. It could not cut prices without losing money on each machine. It could not increase volume without damaging the very process that created its quality. And it could not persuade a market counting every dollar that superior rigidity was worth the difference. Bridgeport, at least, had a vast installed base and an educational ecosystem to cushion the fall. Tree had the respect of the picky ones. Respect, however valuable, does not meet payroll in a casting plant during an industry-wide deflationary storm. What followed was a familiar script in post-1980 American industry: ownership changes and restructuring. The Tree brand passed through rounds of mergers and transfers, each change moving the center of decision-making farther from the Wisconsin shop floor, where the philosophy of tool makers thinking like operators had first been born. The final destination of that journey lay somewhere the founders could hardly have imagined: Zlín, in the Czech Republic, home of ZPS, an Eastern European machine tool manufacturer with real production capability and significantly lower costs. The name ZPS Tree emerged from that combination, and it said everything about the brand's new position. Tree was no longer a manufacturing company in the old sense. It had become a label, a piece of reputational property attached to machines made elsewhere, surviving mainly through distribution and parts support. Original production in Wisconsin came to an end, and with it the last link between the name on the casting and the hands that had once scraped its ways. But Tree's story does not end with a factory door closing, because the machine tool industry has a characteristic almost no other industry shares. its products can outlive the companies that made them, sometimes by a very long time. A knee mill cast from tons of iron, hand-scraped and designed for continuous three-shift work, does not vanish because an accounting office somewhere kills a legal entity. It simply keeps cutting metal, and that is tree's final paradox. The company has nearly disappeared from the industrial map, but thousands of 2UV and 2UVR machines are still working every day in garages, job shops, and mold shops across the United States, many of them more than half a century old and still holding the tolerances that made their reputation. On the used machine market, tree's fate has an irony that is almost perfect. On trade forums such as Practical Machinist, tree mills are often described with the two words every used machine hunter loves to hear: hidden gem. Because the brand is less widely known, a tree in similar condition often sells for less than a comparable Bridgeport, even though many professionals regard its quality as higher. In other words, the obscurity that helped kill the company has become a bargain for buyers who understand what they are looking at. The seller may not know what he has. The sharp-eyed buyer knows exactly what it is. And so the informal hierarchy of the trade, Bridgeport for everyone, tree for the picky ones, continues in the used market, only now it operates through price rather than reputation. A better machine, selling for less, because almost nobody remembers the name. It is hard to find a more concentrated illustration of the entire story. From tree's fate, there is a lesson that reaches far beyond machine tools. In industry, the company that defines a category and builds the training ecosystem owns collective memory. Bridgeport understood that, whether or not it understood it consciously from the beginning. The company that merely builds the best product owns the respect of a smaller group, the people knowledgeable enough to see the difference and demanding enough to pay for it. Sometimes, as tree's history shows, that is all. Respect does not build a moat. It does not carry a factory through recession. It does not keep a name alive in mass memory. But it is not nothing. It survives in stories passed from old machinists to young ones, in forum posts about used machines worth hunting down, and in every moment when a knowledgeable buyer hauls home a machine the market has priced below its true value. The company changed hands so many times that the path is difficult to trace cleanly. The original factory closed. The name on the casting stopped being mentioned almost everywhere outside the forums of people inside the trade. But the machine still does exactly what it was designed to do, in the precise way the machinists in Racine wanted it to do it, long after all of them are gone. Perhaps that is the only kind of legacy a company like Tree could ever have. If you enjoyed this video, like, subscribe to the Gear Archive, and leave a comment with your thoughts. Thanks for watching, and I'll see you in the next one.